Assalamu alaikum. Hello everyone. This is the sixth class of CS224 and today's video is gonna be about I-type instructions, how to change the hex code to a machine instruction and vice versa, which is literally how to change the machine instruction to hex code. And finally, I'm gonna talk about branch if equal instructions and how to do the same with both converted from hexadecimal from hexacode to machine code and converted from machine code to hexacode and so on. All right, see you in the next clip. So let's say I want to change this machine instruction to hexacode. First step is to change all of this hex code to a binary numbers. Each number is made of 4 binary number. Wait, first of all, I need to change all of these to binary numbers by having the basic format code. Let me bring it and come back. All right, here is the basic instruction formats. Our instruction type is I-type, so we're going to be focusing on this table. All right, after I brought the basic instruction, I don't know the name, but whatever it is this table or it is this row. After this, I need to bring the instruction from the green sheet. So I'm gonna bring it and come back. Okay, now here is the instruction. It's add I, right? Add I. We have rs sign extension immediate, which is this one, and we said that I type any format other than 0 is not an R type. So the op function, right? The opcode here is 8 hex. So this means it's not R type because we said R type contains 0 in its opcode. All right, as we said earlier, first step, connect the lines. So this is RT, right? And this is RS because this is how the code is written in this way. It's written this way. We call this the function, I believe. It's not the function, it's called the operation, and as you can see, add immediate operations rt rs sign extension immediate. Okay, I guess now we're ready to connect the lines. First of all, let me just get rid of this. All right, cool. So t1 is gonna be rt, s5 is gonna be rs, and 10 is gonna be our sign extension immediate. Now I need to change t1 to binary, as we said, or first I need to change it to a decimal number or a hexa number, and then change that number to binary, to set of binary numbers. So let me bring the numbers and come back from the table. Which table? It's gonna be this table. So I'm just gonna copy the numbers we got. We said it's gonna be T0 and S5, so I'm gonna bring them and I'll come back. Alright, I brought the numbers. RT, which is T1 is 9, and RS, which is S5 is 21. Now I'm changing them to binaries in 5 bits. Why? Because we said RT and RS are 5 bits. As you can see, from 25 to 21 is 5, and from 31 to 26 is 6. This is 6, this is 5. So 6 plus 5 plus 5 is 16, and the rest is also going to be 16 because usually the total is 32, as like last time in R-type functions. In R-type basic instruction it was 32. In I-type is also 32 bits. What does 32 bits mean? It means 4 bytes, and 4 bytes create one word, which is one instruction, as you can see. So basically the immediate is 16 bits, from 0 to 15 is 16, and RTRS is 5, and opcode is 6. Okay, as you can see here, I just wrote 9 in binary numbers in 5 bits. You might be asking, why do we have this 0 here if 9 can be written as 1001? It is actually true that 9 can just be only written as 1001, but as we said earlier, RS is 5 bytes, therefore we need to have like a 0 in the front so it doesn't change anything of the 9, so 9 stays the same, and at the same time it's 5 bits. And here RS, which is S5, is 21. Now the immediate, which is 10, basically we're just gonna change 10 to number of we're just gonna have 10, but like in binaries in 16 bits. So basically 1, 2, 3, 4. This is the four bits, which means it's one hexa number. So it is 0, and then 1, 2, 3, 4, and this is like the 8. So this is 4 bits, this is 8. Like total, this is also 4 bits, right? So it's gonna be 0, and we do the same. 1, 2, 3, 4, and this is also 4, which is gonna be 0. And now finally the rest, I'm just gonna change it here. So how we write 10? We basically write 8, 0, 1, 0, and this is 0. This is 1, 2, 4, 8. We have 8 here, and we have 2 here, which means it's gonna be A in hexadecimal. So basically 0, 0, 0. Wait, let me change the come back. Alright, so I just moved them from here to here. So basically 1, 0, 1, 0 stands for A, and the previous zeros are the previous bits are gonna be 0 because we just want 10, right? And this is how to write 10, and this is basically 10 in decimal. So let's just start coding. I mean, let's just start changing the numbers to bits. Okay, first of all, we're gonna write the opcode. We said that the opcode is 8, right? So basically 8 is written as 0. Wait, we don't want this anymore. We said we want it this way, right? Okay, 0, 0, 0. These are the first 3 bits. And 8 is written as 4 and 2. So we have 1, 1, 0. Right. Wait, let me. Okay, cool. This is 1. No, wait. This is 1, 2, 4, 8. So 2 plus 4 is 6. It's not 8, so there's a mistake. Oh, wait. I'm so stupid. This is 8. Wait, let me do it again. Okay. 1, 2, 4, 8. Yep. This is the opcode. This is basically opcode. Then we said, oops, we said we keep distance after each 4 bits. So boom, these are 4 bits. Next, we have rs. What is rs? Rs is 5, as you can see here. Wait, with a different color. Let me change everything back. As we said earlier, S5 is rs because we have the what do we say about this? We say this is the operation, yes. RT is equal to RS, so RT is T1 and RS is S5. So basically we're just gonna write 21 in bits, in 5 bits. So we have 1, 0, 1, 0, 1. So I'm just gonna go here, 1, 0, space, wait, 1, 0, 1, 0, 1, and then put space after 4 bits. 1, 2, 3, 4. Boom. Cool. Next, what do we have? We have RT, and RT is 5 bits, and RT, as we said earlier, it's 9. This one is going to be here, 9, which is 0, 1, 0, 0, 1. So we go back here and we then write 0 space 1, 0, 0, 1. So it's 4 bits. And then what's left? We have sign immediate. We said that sign immediate is going to be 16 bits. So it's going to be basically 0, 0, 0, A. Wait, it's capital. A in hexadecimal, because if we, as I said earlier, 10 is basically only A, which is 1, 0, 1, 0, right? So the rest is going to be 0, so it doesn't change. If it's negative, if 10 is negative, we would like take these zeros and 1, 0, 1, and then we're going to do what we have learned in CS223 by changing a number from positive to negative by double sign or something. I don't remember, but when it comes, I'm gonna do it. Okay, I said to myself, let me teach you how to change let me change a positive number from decimal to a negative number in decimal, and also the same in binary. And also there is a trick, so you don't need to do what you have learned in CS223. There is an easier trick you don't need to worry about. So basically we have 10 decimal, 10 as a decimal number, and it's written in, you can actually ignore these zeros, right? You can ignore these zeros, but since it's related to what we're doing here, which is 16 bits, I thought like of saying it, but you can ignore it. But what if the 10 decimal is negative? So let me write it and come back. Alright, so basically, in order to change a number from positive to negative, you need to use two complements, right? But there is an easier way. First, you're gonna look at all of the zeros behind the first one. So we have the zero here and we have the first one, right? And then all you have to do is to like keep all of these zeros, don't do anything. All you have to do is to change what's after the one. So all of these are gonna become the opposite. So this is gonna be one, 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 and this is gonna be 0, 1, 1, 0, I believe. So let me write it on Google and come back. As you can see here, I wrote from decimal to binary, -10, and binary to sign two complements is gonna give you all of the four digits. So this is one, this is F, and this is another F over here, and here there is another F, as you can see. And then we change these to 0110, which is literally the same as this 0100. So basically, let me tell you what I have done earlier. All you have to do is to keep all the zeros before the first one. So let's say I have like this one and I have like three zeros, right? And let's say 10101, right? So how to change this number to a negative number? This is positive, right? To change it to negative, wait, let me go up. Okay, cool. To change it to negative, you're gonna keep all the zeros the same. So in a different color, purple, let's say purple. 0, 0, 0. You see the first one, alright? You see the first one, you're just gonna copy it as it is, like this, and then change everything after that first one. So we have 1 here is going to be 0, we have 0 here is going to be 1, we have 1 here is going to be 0, we have 0 here is going to be 1, we have 1 here is going to be 0, and so on. So this is basically what I have done. 1 1 1 1 1 1 1 1 1 1 1 1 0 1. This is the first 0 from the most right, so we keep it as it is. We keep what's behind it, which is this 0 as it is. So basically, this is how to write -10 in decimal. So I'm just gonna take this number and put it here and come back. Alright, and this is -10 in decimal, -10 in binary. So in case they give you -10, like instead of, like in my example, I was lucky, so this 10 is actually normal 10, this is positive 10. In case if they give you -10, you know what you're gonna do. You're gonna write 10 in decimal this way, and then you're just gonna switch everything after the first one. Cool. Coming back to what we said that we're just gonna change. Okay, so this is, let's say, let's do the first. Let's do what we have been doing. This is the opcode, the first 6 bits, and then the next 5 bits. 1, 2, 3, 4, 5. 5 bits is gonna be RS. So this is RS, and then next we have RT. And now I need to write 10 decimal in an immediate form, and this is basically gonna be, I need to change this 10 decimal to binary, and to make it as it like in 4 number in hex. So I have 1, 2, 3, 4. So I'm just gonna take this number as it is, like without wasting time, this, and then I'm just gonna put it here after this. I hope it works. Yep, and it works. Now let me just fix. Okay, cool. And all of this is gonna be, as you know, it's gonna be immediate. You just can write IMM as a shortcut. Now let's take them 4 by 4. Okay, let's take them 4 by 4. So I know that's gonna be 2, this is gonna be 2, this is gonna be 10, which is A in hexadecimal, and this is gonna be 1, 2, 4, 8, this is gonna be 9, 0, 0, 0, and this is gonna be A. And that's it, that's my answer. 0x, wait, let me go down a little bit. Okay, cool, here's better. 0x22 A9000 A. Let's check the code if it's correct or not. Execute. 22A9000 A. 22A9000 A. This A, capital, small, doesn't matter. But yeah, let's check the registers. So RT is 9, which is T1. T1 is 9. S5 is 21. 21 is 5. And 10 is written in this way. So this is the first step. This is the first part of what we should be doing for today's video. Alright, so we generated the machine instruction from the hex. Yeah, we we generated the we converted the machine instruction to hex code, and now we're gonna convert hex code to machine instruction. So basically I was given this code, and the first thing I need to do is to change this hex number to binary form. So how am I gonna do this? It's very simple and easy. So I'm just gonna write all the numbers. These are hexa numbers, right? So I'm just gonna write them in binary. Wait. So 3 is actually 0, 0, 1, 1, 1, right? 1 and 2 is 3, and then 7 is actually 0, 1, 1, 1, and then 2 is 0, 0, 1, 0, 4 is 0, 1, 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then I need to add 5, so basically this is gonna be 0, 0, no wait, 4, 0, yeah, 1, 2, 4, yep, 5. So that was the first step. Now I need to bring two stuff. Let me bring them and come back. Okay, now I bring that picture, and now we need to distribute what we got from the binary numbers the same as these pictures. So opcode is 6 numbers, rs is 5 bits, rt is 5 bits, immediate is 16 bits. So basically opcode is gonna be these 2 bits. We have here 1, 2, 4, 8. 4 plus 8 is 12. 12 plus 1 is 13. So this is basically 13. Yeah. And then what we got rs5. So it's gonna be these 3 bits. We have 1, 2, 4, 8, and 16. 16 plus 8 is gonna be 24 plus 1 is 25. So this is 25. And then we're gonna go here, and this is rt, this is rt, so basically it's gonna be 0, 0, 1, 2, 4, it's gonna be 4, 0, 0, so it's just gonna be 4. And so I made a small mistake here, or no, I didn't. Wait, I think I didn't. Well, we will see about it, but not right now. And this is gonna be the hexadecimal, as we said. It should be all these 16 bits. So this is 0, 0, 0, and this is 1, 0, 1, 0, which is 1, 2, 4, 8. 1 is active, 4 is active, 4 plus 1 is 5. So this is basically just 5, which is the immediate. Alright, now let's see a table that has 13 in its opcode, that is I-type instruction. So as you can see, now we are in the green sheet, maps green sheet, and the opcode is actually written in hex. As you can see, like this, we have I type here, we have 8 hex. So basically we need to change our 13 from decimal to hexadecimal, and this is pretty simple. 13 is actually A is 10, B is 11, C is 12, and 13 is D, so this is basically gonna be D. So I just need to search for something that is equal to D. And as you can see, I found someone here, and my instruction is gonna be ORI. So first let me write it and come back. Alright, as you can see, I just write ORI. I don't know what is RS, I don't know what is RT. All I know that RS is 25 and RT is 4. So basically, let me go to the table we have over here, down here, and let me search for 4. As you can see, 4 is here, and it's A0, so basically 4 is A0, right? And I have 25, I don't know what's 25 yet. 25 is 29, so basically this is gonna be 29, right? 29. T29. No, wait. My bad. T9. No. Okay, cool. And that's not over. I need the remind me. I need the operation. Yes, I need the operation, which is, we said it's over here, D. Here is the operation. That's what I need. RT equal RS. So the first thing I have is RT. So I'm gonna write RT in the beginning. Or I and then RT. Where is RT? RT is A0, so basically this is gonna be A0, and then the next number, which is, so RT is done. Now we have RS, and RS is 5. We said that RS is going from here to here, right? And this is equal to T9. So basically, I'm just gonna write here T9. and then the immediate number, which we said it's 5, and that should be your total answer. So 37240005 is the hex code uh, from this machine instruction. Let's go to this one. Let's execute it. As you can see, 372T24005 is or immediate A0 T95, which is the same as here, or immediate A0 T95. Alright, now we are done converting Xcode to machine instruction. We are just gonna go little bit up for branch equal instructions because it has a new trick that I need to teach. As you can see here, I have the branch equal if v0 is equal to t3, jump to function 1. And it seems pretty easy, but you might asking this question. The previous questions we had registers, we had like right number, which is like 5, 10, right? Integer. But like here, you gave me a function one, which is a label. Which what is the number of it? Like what should be the immediate of it? Is it like the address or what? And this is basically not how you solve this, not how you answer it. The answer is kinda like how it's written here. So basically, you check if they are equal or not. If they're equal, you're gonna take the program counter. You're gonna equal to program counter plus 4. Plus 4 here means go to the next line and then count how many numbers of line after the first line and then multiply them by 4. It might be kind of complicated, but I'm gonna explain it right now in the code. Okay, so I thought that we at least start with changing this function code to changing this machine instruction to hexacode, and we stop at function 1 and then I show you how we get it. So I'm just gonna do it real quick and come back. As you can see here, rs is the beginning, so this is gonna be rs, and we have rt, and then we have t3. So I need to bring the table and come back. Okay, so the opcode is here, and I wrote it as 6. I need to make this kind of bigger. Oops. Alright, cool. Yeah, that's fine. And delete this line. And then we have the following rs, and what is our operation says? It says the first register is rs. So basically v0 is rs and v0 is 2. And so on, v0 and t3, and then I'm gonna stop at immediate and come back to you. Okay, now I need to find the immediate, and I made a very easy program over here. As you can see, this is branch equal, the same code v0 t3 function 1. And how to find the immediate, you actually need to look at the code, and then after looking at the code, you need to see how many lines are there. But first you need to count from the next line. So basically here is branch equal 1, right? Branch equal whatever, right? So we leave this line and we start from this line and we start counting the next line. So basically we don't count this one, we just write 1. So here is 1, this is the first immediate one, and then here is 2, and then here is 3. So basically my immediate is 3. Now that might be everything you need to know, but what if I have a pseudocode? For example, my pseudocode is, I want a pseudocode that is made of 2 instructions, which are wait. Alright, so basically all I have done right now is just I edited the code, I added a data section, text section, and I added an array that it doesn't matter how many elements we have, but as we said, we want to count the immediate of branch equal, so we basically start counting from the next line of the branch equal. So we have here add I 0, add I, right? Add immediate, and this is 0, and then we have the first line, which is 1, we have 2, and you might think that this is actually 3, but when we execute the code, right, at line 10 we see that store word, which is this one, store word t1 array t5, this one is made of 3 lines. Therefore this is a pseudocode, so we need to count all the lines. So now we said this is gonna be 3, this is not gonna be 3, this is gonna be 3, 4, 5. So it's gonna be both, all of them, 3, 4, 5, and then function 1, which is this one, we need the first line after it, so this is gonna be 6. So basically it is 6 lines. So the immediate now is gonna be 6 because we just added a line of code that has like three, like it's a pseudocode that is made of three instructions. Like this instruction is made of three instructions, as you see in the execute section. We have store word t1 array t5 is gonna be 1 2 3. It's gonna take three lines of code. Therefore, we started counting from here. Sorry, we start counting from here, right? Branch equal, go one line, right, and then start counting the next line after it. 1 2, we said this is going to be three lines of code, so this is 3 4 5, and then 6, and 6 is after function 1, so basically the immediate value is going to be 6. That in case if we have a pseudocode. Therefore, you need to make sure that the lines of code that's between the branch equal and the place you want to go to is does it have like pseudocodes or not. If it has pseudocodes, make sure to count how many lines of codes does that pseudocode make. Alright, so what we're gonna do, we're gonna delete this, right? So it just was for like explaining, right? So we said it's gonna be 1 2, and this is gonna be 3, because all of them, when we count them after branch equal, yeah, here we go to this line and then we start counting 1 2 3. And why we stop at this line? Because it's immediately after function 1, which is the place we want to jump to. So basically the immediate is 3. We go here and we just write um, we go here and we just delete this line and we just write 003, because it's already obvious, right? We don't need to worry anymore. The immediate is already there. It's just three lines of code. And now we just change this binary to hexadecimal. So this is gonna be 1 2 3 4 5 6, and this is gonna be 1 2 4, so it's gonna be 4. It's 4, so it's branch equal, right? And then we said, oh wait, we don't want to do this, we want to change it to hex number, my bad. So basically this is gonna be 0x, the first 4 bits are 1, so basically 1, and then we have 1 2 3 4, so basically 0, because all of these are 0, right? 1 0, and these are 1 2 4 4, and these are 1 2 4 8 8 plus 2 is 10, 10 plus 1 is b, so this is a b, and then 003. So basically it's going to be the following. Wait, yeah, 1 0 4 b, or b capital, doesn't matter, 003. Are they 8 numbers? 1 2 3 4, 1 2 3, we forgot a 0. Yep, 1 2 3 4, and therefore here is our number. That was in case of the immediate is actually positive, but what if it was negative? So we said that it's gonna be 3 because of this line of code, right? In order to get the immediate, you need to start counting from the next line, and then when you go down, you count with positive. When you go up, you count with negative. So let's start doing this. Imagine that we want to go to, and we change function 1 to main, right? So as you can see here, branch equal doesn't have anything inside it. Sorry, there is nothing under it, so you're just gonna imagine that there is line, right? And then you're gonna start counting from this line to up. So this is -1, -2, -3, -4, -5, and now it's -5. So -5 is, oops, my bad. -5 is, as you can see, branch equal is FFFB. If I take FFFB and put it and change it to decimal, it's gonna be -5. So let's do it. Yep, and as you can see, -5 is FFB. Let's do it one more time. So here is my branch equal code. We start counting from the next line. So I'm just gonna imagine I'm in the next line, and this is, let's imagine that there is a code here. There is no code here, so it doesn't matter. When we go up, we count with negative. So I'm gonna move from line 12 to line 11. That's 1, because this branch equal is made of one line of code. It's not pseudocode, so therefore it's only one step. And then add I, that's 2, and then ori, that's 3, ori, another ori, 4, and add I, 5, and then before add I there is a main, which is the place I want to jump, so I stop. So that's 5 steps, but since I'm going up, it's negative. When I go down, it's positive. So therefore, this is gonna be 1, wait, I'm gonna, 1, -1, -2, -3, -4, -5. Since I'm going up, when I go down, it's positive. When I go up, it's negative. That was just like for explaining. I just wanted to tell you how to get the immediate from branch equal. So thank you so much. Wait. All right, that's it for today. Thank you so much. I have covered everything in I-type instructions. Next, we're gonna talk about J-type of instructions. Thank you so much for today. I hope you to have a good day. See you later.